Hi everybody. Here's a video to help you out with the 5 learning targets on your remote review assignment today for the test coming up, because the test is going to be having to come up as early as possible this week, regardless of all the remote days that we've had. First learning target is to use a graph to write the quadratic equation in factored form. This is very easy overall. There's only 2 critical points you need to look for: the 2 x-intercepts. Once you have the 2 x-intercepts, make sure you know what numbers they are. Start writing your equation in factored form. Y equals one set of parentheses times a second set of parentheses, and it's going to be x plus or minus some number and another x plus or minus some number. It's based on the x-intercepts, but it's based on when, if you plug in those numbers, you get 0. So it's not x minus 1, because -1, our intercept, minus 1 would be -2. We need to figure out what would have to be written to make it 0, and it would have to be x plus 1, because -1 plus 1 makes 0. And conversely, it'll have to be x minus 3, because 3 minus 3 is 0, but if I wrote plus 3, that would make 6. Our goal is to figure out, since the intercepts are at 0 in terms of the y value, neither up nor down, what would you have to plug in to make it 0? Now, this is how most of them work, and at most problems you'd be done, but because this graph is upside down, there's an extra thing to do. You will need a negative sign in front. You can make that a -1 or just a negative sign, and that's how you'd write the equation. Upside down parabolas are multiplied by a negative number in front, but you don't have anything there for any typical right side up parabolas. And we're not going to be working on parabolas that have a leading coefficient in front of like 2 or 3 or some other number. It's either going to be positive and you don't have to do anything, or it'll be negative and you just put a negative sign or a -1 in front. All right, that's learning target 1. Moving on to learning target 2. Give me a second here, getting used to all the steps of the video. For learning target 2, it's pretty much the same thing, writing a quadratic equation in factored form, but we're going to take some extra steps and change it into standard form. So we're going to start an answer with x equals some parentheses with x and x, and we're looking for where the zeros are, where the x-intercepts are. And the x-intercepts are where, if you plug it in, you get the value of 0. So it's -9. We need to do +9 to make that 0, and -2, we'd have to do +2 to make that 0, because negative numbers will have to be added, positive numbers will have to be subtracted to make them 0. Now again, there's a trick to this problem, sort of like the last one, and the trick to this problem is it's high in between, and it's low after the zeros. In other words, when it get really big or really small, as you go far to the left or far right, it's negative. And when you're in the middle, it's higher. Typical U-shaped parabolas, the vertex is at the bottom at the lowest point, but upside down parabolas, it's at the highest point. So we've now written that equation in factored form. We need to change it to standard form. The first thing I'm going to do is distribute that negative sign to both things. -x minus 9 and x plus 2. This is another style of factored form, but I've dealt with the negative number there. Me personally, I like to do a Punnett square. Some of you have used FOIL or other opportunities to solve these out. Oops, and I've already made a mistake. Let me erase that. You'll have to have -x minus 9 on the length or the width, and x plus 2 on the other length or the width, and then fill in your Punnett square and multiply. Oops, once again made a mistake, caught it right away. It's -2x in this box, and it's -18. Lots of negatives here. And so putting it all together, it's y equals -x squared. I like to just combine -2 and -9 and not take an extra step of that, and I'll make -11x and -18. A little complicated because of the negative side. It made everything a little bit more challenging, but overall, it's straightforward. Now again, like the first problem and like the second problem, most of them are not like this. This is only when you have something unusual when the graph peaks in the middle high and then gets very low on the left end and right end. Most of the tables will be the other way around, that it peaks at the bottom. And sorry, it's the low negative numbers or lowest numbers are in between, and then the highest numbers are on the far left or far right, in the extreme negative x's and the positive x's. But when it is a negative there, that's how you'll handle it. Once again, I'm going to be doing examples that are probably of the medium or harder problems. All right, 2 down, 3 to go. Here's learning target number 3. Factor a quadratic by setting it equal to 0. We've been spending months on this now. We were doing this since December, maybe even late November. We're looking for things that multiply to negative 40 and add to negative 3. If you're having trouble, make a list. In terms of multiplying to negative 40 and adding to negative 3, you'd have to have the bigger number be negative. So it could be 1 and negative 40. That'll add to some sort of negative number. 2, 3 doesn't work. 4, 5. You might need a calculator to help generate these. You might not have your multiplication table set. 6 doesn't divide into 40. 7 doesn't divide into 40. These are our only 4 options, which is the only one that adds to negative 3. Just this one here, nothing else. So, you know it's going to be x plus 5, x minus 8. And we're trying to set these equal to 0. What turns out when we do this on our easier problems is that you do get opposites, similar to what we were seeing on the graphs and the tables, by just figuring out, oh, it's the opposites that make it 0. So this comes out to be negative 5, and this comes out to be positive 8, and we've got our 2 answers. You have to remember that when there are numbers in front, like this is a 4x squared, there's going to be other ways to solve that you're supposed to know. But you can try to do this by a Punnett square or the same things. The thing to remember, though, is it's not what multiplies to 25. What's really going on here is we have to put 4x squared in one box, 25 in the other box, and we're going to be looking for things that multiply to 100, 25 times 4, 100x squared, and what adds to negative 20. And there's only 2 numbers that work with that. Those 2 numbers are negative 10 and negative 10. Whoops. Wow, bad handwriting here. There we go. Still bad handwriting, but not as bad. You could finish your Punnett square like this and everything would work out. However, there's a much, much, much faster way to do this. The much, much, much faster way to do this is, hey, did you notice the number 4? Why, that's just 2 times 2. Hey, did you notice the number 25? That's just 5 times 5. And x squared is x times x. And then you'd have to be careful. We have a minus sign here. We need to add to negative 20 in our Punnett square. This is called a perfect square trinomial. And when you have these perfect square trinomials, you don't have to bother with all the steps I did there in red and black. You can. It still works out to the same answer. Anyway, remember our final step. We're trying to set this equal to 0. And for setting this equal to 0, I'd have to make sure I solve to both sides. And notice it's more than just the opposite. Now, most of these I've been getting 2 things. This one here I don't. I get a single answer of 5 over 2. And you could get a decimal if you prefer. If you prefer 2.5, that's fine. These types of problems that are perfect square trinomials only come out to 1 answer. When you have a leading coefficient like that, most of the ones with a leading coefficient, just like our first problem, will come out to 2 answers. However, when they're perfect squares as the first term and last term, and it's the same thing twice, it can come out to just a single answer. And that's when the graph just touches the x-intercept at 1 spot rather than 2 spots. Like it just grazes the x-intercept there. All right. Learning target number 4. Graph. Now, what's the easiest way to graph? The easiest way to graph is to, you probably use Desmos or something like that. Just right now, though, however, you can find the y-intercept. The y-intercept is at 0, comma 15. It's off our graph, somewhere way up there. I can't even put a dot right now. We can't find our x-intercept or vertex that fast, but if we wanted to, we could do it the long way. And so what's the long way? Start plugging in numbers. I know what happened with 0. Let me try out 1. 1 squared times 8 minus 1 plus 15. And that comes out to be, using a calculator if I need to, 8. Oh, cool. I'll make a dot at 1, comma 8. And then I could do that for 2. I could do that for 3. I could do that for 4. It will work. What's the quicker way? For x-intercepts, what multiplies to 15 adds to negative 8. Why, it's just negative 3 and negative 5. Meaning, we know there has to be intercepts there right at x equals 3 and x equals 5. Well, that just made things really nice. And also, in between has to be the vertex. So the vertex is going to have to be at 4, comma something. And I can figure out what it is if I want to plug in 4. If you plug in 4, I can tell you it comes out to be negative 1. Let me do the work here, though. 4 squared times 8 minus 4 plus 15 works out to be negative 1. So I have a dot right there. I can make myself a nice U-shaped parabola now. And notice that the left side's going off my graph. It would go up to 15 if I extended it out. I just can't extend it out at the moment. So write out my vertex, write out my y-intercept, and take a moment to write out my x-intercepts of positive 3 and positive 5. And you could write that as 3, comma 0 and 5, comma 0 if you prefer. So if you need to do this a long way, you need to make a table. And it's okay to make a table. Maybe you don't remember how to factor like I did in blue there with the x-intercepts. The y-intercept's easy to find, whether it's on your graph or not, but the x-intercepts and vertex require you to take some steps. The vertex will always be right between the x-intercepts. You will have to plug in the vertex x-coordinate to find the y-coordinate, but you can make the blue dots and the x-intercept dots and make your graph without having to do a huge amount of work if you know how to factor what multiplies to, what adds to, how do you factor different things. All right, final learning objective is the exact same thing we just did, but in the context of a real problem. We had done water balloons during the chapter. This one's pretty similar. It's a model rocket. This one here, just so you know, is a little bit weirder and harder and a little less exact. I'll talk about it when we get to it, than the one on your review sheet and the one that'll be on your test. But I only had so many examples and wanted to make sure I was doing something that's a little bit different here. So how do you do this? And it's scaffolded here for you. Step 1, complete a table. You plug in the number 5, plug in the number 0. 16 times 0 plus 79 times 0 plus 5 comes out to be 5. And unfortunately, I don't have a calculator right here with me. I remember how this ends, but I don't remember all the values in between, so I'm going to do my best here. Oh, no, I'm not, am I? All right, I am going to get a calculator here. If I have one, which I should. Calculator, where are you? I'm not finding it here. Okay, how do you find a calculator again? There we go. All right, negative 16 times 1 squared plus 79 times 1 plus 5. All right, 68 is my first number. I'm writing it down. Second number here, negative 16 times 2 squared plus 79 times 2 plus 5, 99. Negative 16 times 3 squared plus 79 times 3 plus 5, 98. Negative 16 times 4 squared plus 79 times 4 plus 5. 65. And then, since I made this problem, I know where it's going. Negative 16 times 5 squared plus 79 times 5 plus 5 comes out to be 0. All right. So, it was 68, 99, 98, 65, and 0. So let's put dots anywhere. First of all, 0, 5 is close to the origin, close to 0, 0, but just a little bit between the 0 and the 10. 1 and 68, close to the 70, but not quite. 2 and 99, close to the 100, but not quite. 3 and 98, pretty much the same, a little bit lower. 4 and 65, pretty much the same, a little more in the middle. And 5, 0. All right, so make a U-shaped graph. X-intercepts. The only X-intercept I see here that's an exact X-intercept is 5, 0. Is there another one? Yes, there is one at negative 0 point something, but I don't have a way to find that at the moment, and I don't need to do it. Your problems will have 2 X-intercepts. However, this problem only had 1. All right, Y-intercept. Y-intercept was 0, 5. Not always the opposite. It's touching right there. Let me highlight that in color. That's the X-intercept. There's another one that's just slightly negative, and then you have the Y-intercept there. The vertex has to be pretty much between 0 and 5. I can tell you right now, I made a problem up here that was just a little bit not working out. The actual answer, because there's an X-intercept that's not quite at 0, it's like at negative 0.0 something or negative 0.1. It's actually like 2.46 or 2.47, but it comes out to 2.5. You'd have to use Desmos to find it out more exactly. And then if you want the Y value, you have to plug it in. So as a reminder, negative 16 times 2.5 squared plus 79 times 2.5 plus 5. I'm not going to go back to my calculator. This number I remember from doing it before. Comes out to 102.5. And actually, again, if you use the exact value, it turns out to be like rounded to the nearest tenth is 102.5. It's very close. So what does the X-intercept mean here? Well, it's where the height is 0. If you look back at the original paragraph here, the X-intercept represents, so the X represents how many seconds after the rocket is launched, and the Y represents the height of the rocket. At the X-intercept, the Y value is 0. So the Y value is 0 means it's how many seconds when the rocket is on the ground. Let me make that smaller. Whoops. There we go. What does the vertex mean? The vertex means it's the height of the peak of the rocket, how high the rocket gets when it gets up to its top. So basically, at 5 seconds, the rocket hits the ground, and at 2.5 seconds, give or take, it gets up to 102.5 feet high in the air, give or take. If you're doing a different context, you're doing this pretty much the same context. It's going to be a rocket launch on your review sheet here that this video goes with. And then the one on your test is going to be similar. It's not going to be a rocket. Just have to be prepared for, hey, whatever's going on here, just make sure you're interpreting what they mean. The X-intercepts will be when something is launched into the air, when it's at ground level. And for this one, for the rocket started when X was 0. It started 5 feet above the ground. Like it was on some sort of platform or something like that. And then it took 5 seconds to hit the ground. And then it got up to 102.5 feet in the air. And that's what the vertex means. That tells you how many seconds as the x value, 2.5 seconds, and how high it got, 102.5 feet in the air. They're both very useful information. Hope this video will helpful for today. Enjoy your Monday, and then check Google Classroom on when your test is going to be, but it's going to be on these 5 learning targets. Take care.